Okay, so welcome everyone and those who joined late as well. My name is Nisarg and I am currently pursuing my BTech in computer engineering from NMIMS Mumbai. I'm in my third year and today I'm going to talk about containerization and how and why it is helpful to us as developers. Uh, so, let's begin. I'll start by sharing my screen and hopefully my screen is visible. Is it?
Yes, yes,
Yeah.
yes, yes, yes.
Okay, perfect. So, Yeah. So, also before we begin, this webinar is an interactive webinar. So, I encourage you guys to ask questions. I won't be able to see the Google Meet, so you can just unmute and ask a question. And yeah, as far as what we are covering in today's webinar, we'll be talking about what containerization is and why do we need it. We'll also look at Docker and how we can use Docker to build a container for our app. And after that, we'll look at how to run a container and how to scale the container. And lastly, we'll just gloss over some best practices that we should keep in mind while building containers. Yeah, so let's get straight into it. So, containerization. Like the name suggests, containerization is the process of creating containers or wrapping your application in a container, right? So, now what does container mean? So, in real life, a container is something that basically encapsulates important item. Like say for example, when you get deliveries from Amazon, right? They package your whatever item you ordered in a cardboard box. So that cardboard box is a container, and in in the context that we are using containerization, that is in terms of application as well as in real life, the main purpose of containers is to be lightweight and portable, right? So containerization basically makes your app portable. That means it's easy to run and build on multiple different devices, as well as it's relatively lightweight. Now, why do we need to containerize? First of all, consistency. If you have a container, which is basically you have a small portable environment, right? So wherever that container is running, all of those environments are consistent. There is like they are exactly the same. So debugging errors would be easier. You won't have any OS specific or environment specific issues as such. The other part is scalability. So obviously, if you have like a container, it's kind of like a blueprint, right? So you can scale it easily. You can replicate those containers to have multiple instances running on different servers. And in general, containerization basically just improves your development process. So now, uh, I hope my screen is visible. Let's take our app for example. So the circle here represents our app. I'll just label it. Now I have an application. It could be a simple, server, a simple Express server running. Now I want to host this particular app, or I want to host this particular backend on, say for example, 5 different servers. Right? I'm a company and I'm running my own backend, so I want to host it on 5 different servers. Now imagine I've built this particular app using Python. So I'll mention here. So one of the dependencies of this backend would be Python, right? And I've used Flask, so that is another dependency that I require, which is Flask. Excuse my handwriting, I'm using a mouse. So now if I want to host this on 5 different servers, traditionally I would have to I would basically have to clone this repo on server 1, install the needed dependencies, and then run it. Similarly for the 5 different servers, right? I'll need to clone the repo, install dependencies, and run it. Now, in this entire process, first of all, it's very cumbersome and repetitive. You're doing essentially the same steps on 5 different servers. And the other issue is you may get some OS specific issues. Like the Python version on all these 5 different servers might be different, entirely different. And that might cause issues during your runtime or when your users are using your app, right? So you want your application to run in one particular fixed environment, and that environment should remain same for wherever you're hosting it. Now these are just 5 different servers. Imagine I'm a company like Amazon wherein I have, you know hundreds of servers across the world. So every time traditionally, doing this, building it on the server, installing dependencies, making sure everything is the same version, it's very cumbersome. So I can just I'll just erase all this. Yep, perfect. So what I can do is I can, yeah, I can take this app, right, and I can take a container here and encapsulate my app inside that container. Now this container will have the particular Python version that my app requires. I will also install whatever dependencies I require. Okay, in this case it is Flask. And I'll basically run the app inside the container itself. So imagine this to be kind of like a mini server. It's not really an entire server, or else if you're familiar with the concepts of virtual machines, the concept is similar to that, wherein you are creating an environment like a virtual environment. But containerization does not have entire servers or entire machines inside the container. They just have whatever environments you require your app to be run on, right? So now I'll take a real life example. Imagine you have 10 friends and all of them want to eat Maggie. So, and you know how to make Maggie, right? But none of your friends know how to make Maggie. So, if you were to use the traditional approach of deployment, you would have to go to each friend's house. Okay, friend one. You would have to, basically ensure that they have all the ingredients you need to make Maggie. And then you need to make Maggie at their house. So basically, you'll need to go to 10 different houses and do the same thing. Whereas if you containerize it, which is basically what this diagram represents, you create an image. So this is the technical term, image. Okay, so you create an image, but before that, you need to have something known as a Docker file. I'll just type it out. You need to have something known as a Docker file. If you're using Docker to containerize app, which is what we'll be talking about in this webinar, so you need to have something known as a Docker file. I'll have it here. So a Docker file is nothing but it's basically you setting up the environment. You are setting up your container. So in the Docker file, you'll mention what image image you want as the base image, and what particular commands you want to run on it, and those commands would basically be installing the dependencies, etc., setting some environment variables, and then actually running the app. So you need to have a Docker file, which is the configuration. Yeah, basically like sharing it via Tupperware containers. Actually, I'll give you a better example. So yeah, instead of me going to 10 different friends houses and creating Maggie for them, if I have the Docker file, which is like the recipe of Maggie in this case, even though Maggie does not require a recipe, but just assume it does. This is my recipe, right? So I have another option. I can just give this Docker file to my servers, or in this case, I can give my recipe to my friends, and they can build the Maggie, or they can cook the Maggie on their own, right? Now this is a better step than the traditional approach of deployment, but you can go one step further, which is using this recipe. You can create a container or an image. Both of them are slightly different. A container is just a running instance of an image, right? And in our example of Maggie, it would actually, Maggie was a bad example, but it would be something like a packet of Maggie, right? Like the packet that the company gives you, wherein you have the ingredients inside the packet. You also have the instructions inside the packet, and it's as simple as adding water. So if you have the image basically on your server, you can just give this image to your servers, to your 5, 10, 100 servers, and they just need to run this image. They don't even need to build the image, right? So you don't even require they have something more than a recipe now. So they don't need to do any building or cooking. They just have to run it. I hope that made sense. If there are any questions, you guys can ask me here. If not, we can move on to the next section. And yeah, obviously, containerization, helps solve the
Time to
issue
drink
of
water, you
it
stupid human.
works on my machine. So basically, while developing an application, right, you might have some libraries that you have installed locally. You might not be aware of them, but your application might be using them. So you don't get any errors on your particular machine. But when you go to deploy it on a server, you haven't taken into consideration those particular dependencies, and therefore there might be some errors that exist. Another scenario is if you are developing using Windows, and most servers run Linux. So the environment essentially, or the OS itself, is quite drastically different, right? So there might be some issues when you go to deploy your app. So now actually let's take a demo and let's actually, containerize an application. So here I'll just open my editor. I have a very simple Express app. Okay. If I run this, node app.js, it's running on localhost 8000. And if I were to call localhost 8000, which is just, I'm sending a request and asking for a response, I get hello world, right? So I have this running. So now how do I containerize this? So like I mentioned, you need to create something called a Docker file. And now the LSP is, indicating you need a source image, and the keyword for that is from, and then you have to give the base image. So now you can use Ubuntu, which is like the entire Ubuntu server, like a very lightweight version of Ubuntu. But for a simple Express application, I don't need the entire OS, right? I just need Node, which is the runtime for JavaScript. So, but I don't know exactly, if that exists, if that is a valid base image or not. So I can go to hub.docker.com, which is basically Docker Hub, and I can search for Node. So I can search for existing, images, and even user created images. Here, I'll just make that full screen. So now on the left, you can see trusted content. If it is green in color and it has this badge, it is an official Docker image, which means that this image is provided by Docker themselves. A blue tick is a verified, publisher, similar to like how you have YouTube verification or Instagram verification. And a purple thing is sponsored OS, open source software. So it just means that that particular project is sponsored, and it's, ideally actively being maintained. So you increase, like, the trust factor increases. But we do have an official Node image, so we are going to use that. Now when I open that up, now you can see something known as supported tags and respective Docker file links. So here they directly provide the Docker file for you, so we'll look at that as well. But there are so many different tags, right? So these are different versions, and tag basically mean versions or variants, whatever you'd like to call them. But what I'd like to point out a few, like for example, 23-Alpine 3.2 basically means that it is running Alpine in like as the quote unquote OS or the server, instead of like a full-fledged Ubuntu server or something like that. Similarly, we have 23-Bookworm. You also have current-Slim. And if you don't have any idea on what to use, like, you can just use Node without any tag, and it would basically, use the latest tag. So how do you specify that? So firstly, you need to give your image name, and then a colon, and then the tag. So here I can write 23-Alpine 3.20, and that will also work. Or I can also specify latest. Okay, for now, for simplicity, we'll just use latest. And also we can look at the tags tab here, and you can filter tags. So you can sort by newest, and you can search for something like slim. If I want the slim variant, right, I can search for slim. So yeah, 22.12.0-slim is the latest slim version, and it was last pushed 13 days ago. And also you can see what OS it is basically running on, like using internally. And you can also see the vulnerability. So it has one high severity vulnerabilities and 24 low severity vulnerabilities. So usually slim variants aren't updated that frequently, and are they prone to be more they're more prone to having vulnerabilities. But again, those are not really that severe, and you can have a look at it in depth. and that's why but instead of using the latest one, which would be slightly heavier, you can use something like slim. For now we'll just use latest. Then you need to specify a work directory. So this basically means what directory that your container will be running the app on. So we can just use /app. You can literally give any name, any location. Now you'll need to give some commands. So I'll just open my file tree here. For Express app, you obviously have your package.json, which is kind of like your requirements.txt in Python. It just is a list of dependencies, etc. So you'll copy package.json to your container. So now the copy command, what it does is it takes a file or a directory as a first parameter, which should be on your host machine. So that is the machine that is there physically with you. And then the second argument would be the location inside the container. So in this case, // will refer to app because we have set the /app as the working directory, right? So I'll just copy it. Now the next command would be to run npm install. That would just install all the dependencies, and then copy /. So now what this does is basically it copies everything from my host directory, everything to my container, and to be more specific, it will copy everything to the working directory of my container. And then cmd stands for command, and it basically runs a particular command inside the container. You can just run npm start, but in this case I don't have any, you can see my package.json, I don't have any start scripts, so I can simply run node app.py app.js, right? Now I have created a Docker file. Now the next step would be building this Docker file. So before that, let's actually take a look at how to install Docker. So that is docker.com, or actually you can just refer to docs.docker.com. Yeah, so basically this is a brief overview over Docker. For Windows and for Mac and for Linux as well, you can install something known as Docker Desktop. So that is basically a GUI that helps you manage all your Docker images and instance containers and everything, like the screenshot shows. Here it's showing running containers and how much CPU they are using, and if they're running properly and what ports they have exposed, etc, etc. And if you click on learn more about Docker, it just installs the documentation. So basically, yeah, to install Docker, you can go here and say, for example, install for Windows, and then it'll install the exe. I'm using Arch, so I just install it via my AUR helper. Although I think it might be in the official repos. Yeah, it is there in the official repos. So I would suggest if you're using Linux, install Docker and something called Docker Compose. Both of them are there in the official repos. And Docker Compose, I'll get to that later. But yeah, so that is how you install Docker. Now, one thing we forgot in our Docker file is, actually I'll just show you. We aren't exposing any ports, right? So by default, the container has its own network, right? So none of the ports inside the container are exposed to the host. You have to explicitly mention what ports you want to expose. Now, if I look at my app.js, I am running it on port 8000. So I can expose port 8000 here. And now the next step would be to build. So the command for that is docker build, and all of this is relative to your present working directory. So you can't run this from anywhere in your PC. You have to run it from the directory in which Docker file is there, or you'll need to pass the Docker file. Then I'll use a flag -t, which just stands for tag, and I'll just name it as my app for now. And then I'll just pass in the current directory. Okay, so it cannot connect to the Docker daemon, so I need to first run the Docker daemon on my system. Just start Docker, enter my password, and I entered the wrong password. No, I did enter the correct password, and I can try building my app again. So as you can see, it basically runs all the steps in chronological order. It will pull the images. So step 1 was from node latest. So it'll pull library /node, which is basically it's pulling this image, right? while we are waiting, we can talk about something else. So yeah, there are different commands like docker build, which is basically used to build a container. Then we have docker run, which will be used to run a particular container. And then if you just do, pass in the help flag, you can get the list of different flags that you can actually pass. Docker run help. And if I do something like port, so you can actually pass the port that you want. So publish a containers port to the host ports -p, and then capital P would be publishing all ports. So that is how you can expose all the ports inside a container to your host systems. And then you have docker ps, which just lists the running containers. So now I have two. It does not list the wait. Oh yeah, it does list the running containers. So I have two containers running basically on my system. And then there are different commands you can check out, like docker images will show all the images that you have locally, as well as the images that you've pulled. I think for this particular webinar, we'll require only that. So yeah, like you can see, step 1 was pulling the image, then downloaded newer image from node latest. Step 2 was setting the work directory. Step 3 was copying the package.json. Step 4 was running npm install. Step 5 was copying all the files from my current directory. Step 6 was exposing the port, and step 7 was actually running it. So now I have built the image, but I have not run it, right? So if I do docker run and then I pass in the tag, that's why we tag the image, right? If I do docker run my app, it will run the image. But now if I go to, I'll just close this. If I go to call localhost 8000, I won't get a response. That is because I have exposed the port 8000 from my container, but I haven't mapped it to any of my host ports. For that, like we saw before, I can pass in the flag P for port, and I can do something like just to show a difference, I can do 3000 colon 8000. So the syntax for this is anything before the colon refers to the host, and anything after the colon refers to the container. And this is not just for ports, this is for most of the Docker configuration, right? And if I run it using this, now again, it is running my app, and therefore whatever is getting printed to the standard output is from my app. So that's why my app is printing server running at localhost 8000. Again, if I curl localhost that was 800. But anyways, if I curl localhost 8000, I wouldn't get anything because I have mapped the containers 8000 port to the host system's port 3000. So I'll need to change that to 3000, and now I get my hello world running. So this was a simple look at how you can build images and run them. Any questions so far? I'll take that as a no. Now the keen-eyed among you might have wondered something, that is, I'm copying the package.json here, and then I'm copying everything again here. So why can't I just move this here and skip this step? I absolutely can. But Docker, while building an image, it follows the chronology that you've mentioned in the Docker file. And while rebuilding some existing image, it caches the layers. So each of these commands essentially is one layer, right? So it caches those layers. And if it has a cached version existing without any changes, it would use that layer and make your build process quicker. So the reason why we, copied everything after we copied the package.json and installed the packages is because if I go in my app.js, make a change to, use the env port. So I don't know how env.port. Is this correct? I'll just ask ChatGPT. Or I'll just ask it to fix my code. Oops. Should be correct. But if I just change it to port 3000 by default now, I'll show you what happens. Process.env.port. Okay. Here. Oops. So that is process. I'm not a JavaScript developer, so don't come at me for that. But yeah. And now I have to expose port 3000. So as you can see, I have made a change in my code, right? But I haven't changed any dependency. So my package.json is exactly the same. Plus, another thing I can do is, because I mentioned, I'm reading the port from my environment variables, and if there isn't any mention, then I'll use 3000. I can also pass environment variables in my uh, Docker file, and for example, here I'll just pass something like 5000, and then I can just expose 5000 because then it would be running on port 5000. Now, if I go to build this using Docker build dash t my app dot, you can see it it has basically skipped steps 1, 2, 3, 4, and it says it's using cache because none of those files have changed. It's using the existing cache that it had from the previous build, right? That's why we copy the package.json file and install the dependencies before copying everything. And then it also removes the previous containers, etc., etc. Now, while we are at this, we might as well just come towards the best practices. So the first point is keeping containers lightweight. Uh, in our case, it would be using something like a slim version of Node because we don't need all like a lot for this. So we can have something like what, something like slim. The tag might not be correct, but just assume it is. Then using multi-stage builds for optimized images. So what this refers to is if you have a very complex app that you need to build multiple different things in order for your application to be built completely, you can, in the same Docker file, you can do something like from node as builder, and then here you can do something like from builder and then have another configuration. So what would happen is a part of your code would be built, and then the built binary would be used as the base image for another part of your application. That might not make a lot of sense now, but uh, just know it's good practice to break down your builds if you have different levels of or different build processes in order to build your entire application, right? Uh, then the other thing is avoid storing secrets in containers. So then, because you can pass environment variables, does not mean you should pass API keys or any sensitive data in your from your Docker file to your container. You should be using env files on the server because Docker allows you to pass env files to containers while running them. And the last thing is use health checks for better container monitoring. So basically you can define health checks, and for this something like a health check would be something like it would ping, yeah, let this thing suggest this thing. So yeah, health check interval is 5 seconds, timeout is 5 seconds, retry is 3, and it would just basically curl the localhost port, or else it'll throw an error. So basically it's a simple health check. It's just pinging my app or my express server, and if that entire thing fails, the health check will basically say that it's not healthy, right? So let's just include the health check because why not? Now, yeah, another thing when it comes to good practice is, because we want our containers to be as lightweight as possible, this ideally can create a lot of issues. Okay, this can create a lot of issues. I'll tell you why. Because my current working directory also contains node modules. So in this particular step, my node modules are also getting copied over, and essentially they are overwriting the node modules that this particular command runs, right? That is not a good thing. And similarly, you wouldn't want to copy notes.md or the log files, etc. So similar to how we have a .git ignore, we also have a .docker ignore, in which we can mention node modules. The syntax is exactly same as git ignore. Then you have anything that ends with md or anything that ends with YAML, or actually instead of that I should just copy this and paste it here. So now it won't copy over those files. So now I can build it again, docker build. Again, it'll use the cache except from where my layers are changing. And if, for example, layers, I have 9 layers here. If for example I have only changed layer 6, uh, so up to layer 1 to 5 it will use cache, then layer 6 it would build again. But even though layers 7, 8 and 9 are the same, they would be built again. So what happens is wherever it encounters the first layer to be built, every layer after that will be built again, regardless of having the cache, regardless of there being no changes, etc. So that's why the order is very important. Yeah, so we have built the image and we can again run it. Docker run, again I can pass in the ports like port 3000 to 5000 because we passed that in the environment variable, and I will just run my app. Already allocated. Okay, port 3000 is already allocated. What? Okay, this is a good chance we can look at our running containers here. So as you can see, I have these containers running already. If I do docker ps, it shows me all the running containers. So because the previous command that I run, it actually ran like we binded port 3000 and it's already running. That's why it's showing that you can't bind that port. So what I can do is docker stop, and I can just stop that particular container. Or you know what, that's taking time. I can just bind another port. I can bind port 5000. So now if I do curl localhost 5000, I get hello world back. So now this was a very basic example of how you can containerize applications, and I hope you guys understood that. Are there any questions so far? Okay, I'll take. Yeah, sorry.
Yeah,
Yeah, go ahead.
I posted one in the chat. Yeah. My question was, so yeah, you can just read it out.
Okay, I'll read it out. Does it skip duplicate copies? So while you have your packet.json cached, does it not recopy the files already copied separately as previous layers? So wait, I think you mean to say that we are copying package.json earlier and then we are copying everything. So will it recopy
That's right.
package.json, right?
Yeah.
Yeah, it will recopy package.json because it wouldn't know what files you've already copied. And basically whenever you're mentioning copy dot space dot, you're copying everything from your host machine to your container, and it will recopy all the files. It's basically something like cp space just showed here cp space r here, so it'll copy and overwrite existing files. And that's why the order is important. And if you have a Python app, for example, you'll copy the requirements.txt first, install all those requirements, and then copy the rest of the files. Yeah.
Okay, so just to run the install command is why we're just copying that specific
Yeah,
one
yeah, yeah, yeah. Just to
at
run
first. Okay.
the install command, we are copying the package.json or the requirements.txt, um, because those are less likely to change than your code, right? So you wouldn't want if you copy everything, that's okay, but then basically the next command would be installing dependencies, and that command would get run again. Wait, I'll show what I mean. So here on my screen, if I just copy it directly here, I'll still need to do npm install, right? Because I haven't installed, I've just copied the files. So what would happen is whenever I make any change in any of these files, this particular layer would get rebuilt, and this layer would also get rebuilt, even though my dependencies might not have changed. So what is happening? You're just running this layer, like building this layer again, even though there's no need to build it again, right? So that's why what you do is you copy the requirement, like the dependency file, which is package.json in the case of JavaScript or Node apps, or requirements.txt in the case of Python. You copy it before copying everything else. You install the dependencies, and then you copy all the rest of the files. So what happens is if I change my code, which is basically rebuilding this layer, and I don't have any additional dependencies, I don't need to reinstall anything. Or so basically this command won't get rebuilt. It'll use the cache for this particular layer. Does that make sense?
Yes, so you're selectively running the layers then.
you're not selectively running the layers. So Docker by default runs the layers in order that they are, mentioned here. So because you are copying the package.json and installing packages before you are copying everything else, both of these layers run before it copies, right? So if I make a change in my code that does not affect package.json, therefore it will use the cached version of this while building the package. And again, npm install is just a command, so it'll use a cached version because none of the previous layers have been modified. If
Okay.
if I change package.json, this would get rebuilt, and all of the layers after that would get rebuilt. And which also
Okay.
makes sense, because if you're changing package.json, you'll again need to rerun the npm install. You wouldn't want it to use the cache. So I hope that cleared the question.
Yeah. Thanks.
Yeah. Okay. I think we have another question. Okay. I think, yeah. If the file isn't changed, it just skips it. So yeah, it just skips it. It uses the cache to build the image. Yeah. So I think that's all the doubts. Now we will look at scaling containers, right? So before that, I would like to talk about something called Docker Compose. So that is another command or another program that you can use. It has multiple different commands that you can use, like attach, build, etc., etc. And what it allows you to do is, I'll just show you something here. Imagine you have an entire application, right? A full stack application, which has its own, which has its own backend. It has its own front end, and maybe it has another middleware in between. Okay. And you have containerized. That was a bad example, but imagine the circles are the backend, front end, and middleware. So there are three parts to your entire app, right? And you want to deploy this entire app. So what you can do is you can create Docker images for each of them individually, and then build them and then run them individually on the server. But you're running three different. You're running. My bad. You're running three different. Wait, do I need to select it every time? You're running three different images, and then you need to expose the ports of these containers to your server ports, and then internally they would be communicating via the server, right? But all of those images are a part of the same application, right? So what you can do is you can call these services instead of images, and basically group them into one Docker Compose file, right? So you can basically create a mega recipe in a way, right? So imagine I want to create something like ratatouille. So for that, I need to create noodles as well. I need to create the gravy as well. I need to do a lot of different things. So all of those are individual Docker images, but together they create one entire big dish, right? So instead of running them individually, I can just have one, common environment, even though technically the environment is not common, but I can basically containerize those containers, if that makes any sense. And Docker Compose is what we use for that. So like Docker has Docker files for images, Docker Compose has docker-compose.yml. Okay. So now I'll just log into my server to show you. Actually, I don't need to do that. I have a project that I can show you. So here, I have this project. It's I'll just open main.py. It's basically a Flask app that is a simple temporary file sharing solution. Okay. So now for this, like you can see, I have my Flask app itself, and I also have a Postgres database running, right? So I have two different images, and I can technically, Docker does have a Postgres image which I can run. Here, if I search for Postgres, so here there is an official image for Postgres. So instead of running two different images, one for my custom app and one for Postgres individually, I can have a Docker compose.yml. So you can literally ask ChatGPT to create this file for you, or you can look online for syntax. But each of my quote unquote images are services. Okay, they are inside services, and this follows YAML, syntax. You give the service a name. So in my case, I have given DB as a name for the database. You give it the image that you want to use. So Postgres, and the tag is 13. Environment, you configure some environment variables here. Now, one thing to note is if you're passing an env file, any environment variables mentioned directly in the Docker Compose file would override those env variables, right? So it is useful in this particular in such cases wherein you're creating a database and your app is using that particular database. So I can literally pass the same parameters here, and the user does not need to specify these parameters anywhere in the env file, right? Because the database would be directly my app would be using the database that I have run inside the Docker environment, right? So here, and similarly, what other thing you need to do is you need to pass volumes. So here, what you can do is you can link any file or directory on your host to your container, and this would be live. So while your container or while any of your containers are running, the files would be updated, like they're actually linked during runtime as well, not just while building. So they're not getting copied over, they're getting linked. And this is how you specify it. So I have a folder, I don't have it here, but um, postgres underscore data. So if you don't have this particular folder mentioned, it while building this or while running this Docker Compose file, you'll basically it will create an empty directory for you, and then that I'm mapping it to /var/lib/postgres/data inside the container. So basically I can access this particular folder inside the container from my host machine itself, right? Then I need to specify networks. So because my database and my app need to share the same networks, I create a custom network called app underscore network and then pass that as the network for both my services. If you don't do this, all of those services would be essentially running on different networks. So they won't even be sharing the local host, or they won't be sharing any networking, like they won't be sharing a network. But if you pass in the network explicitly, they would be sharing the network, although they would be considered different devices. So they would have essentially different IP addresses. So you technically can't just use localhost in your app anywhere. You'll need to use 0.0.0.0 instead of localhost. Again, you can pass in health checks. Then your test would be PG ready. This is just Postgres checks, intervals, retry, start period, etc. Then my other service would be my app. Again, I've named it app for simplicity. In my build, I don't pass in an image here. You can see either I can pass an image or a build file. So I passed in my build file, and dot represents the current directory. So my current directory has a Docker file already, so it will use that by default. Or I could do something like app/Docker file, something like that. Okay. Again, same. I can pass in environment parameters, and like my comment mentions, other environment variables would be read from the env file. Then I can pass in a user. So when I was deploying this particular app, it was giving me some permission errors, so I just passed in the user. It's not compulsory. I can mention what env file it will accept. So if I mention env file, I don't need to pass in the env file in the command itself, right? It will know what file to look for as the env file. Ports. So now I have only mentioned 5000 here. I haven't done something like 3000:5000 because I do not want to map it to my host system. I just want the app to expose its port 5000, which my Nginx instance would be reading, right? Similarly here I don't have a port as such, but because it uses the default, like my app just checks for the default here Postgres port. So if I haven't mentioned any colon in my ports, it just says that expose port 5000 of the container to its local network. So it won't be accessible on the host machine or on the server itself, but it will be accessible to other images that I'm running. So to my database image and to my Nginx image. That was the port. Now this thing, deploy. So here this is how you scale it basically. So you can mention the number of replicas that you want. And in that you can have different configuration also, like how many resources it should use, etc, etc. For simplicity's sake, we are just mentioning the number of replicas. Yeah, let me have it as 1 by default. Now depends on, so basically what this configuration does is, you mention a particular service. Here I've mentioned DB because that's the name that I've given. and then the condition. So basically it will wait for my DB service to entirely start before starting my app, which makes sense, right? Because I wouldn't want to run my app before my database is running and ready, right? So that is basically what this does. And the condition I pass in is service healthy, which means that only if the health check passes is when you'll run the app. Again, network, same thing. I'll pass in the custom app network. Restart always. Means that in case there is some error and this particular app, crashes out, Docker will basically restart it. And the condition of restarting is always restart. This thing is restart. Wait, I don't remember the exact syntax. Restart if it crashes. So on failure, which means that only on failure will it restart. But always is a good option, like a safe option. Again, volumes, this is mapping my local directory to my container directory, similar things. So I do have a data directory here, which I'm mapping. So I can basically access this particular, I'm just linking those directories. That should be self-explanatory. Now, Nginx. The reason I'm running an Nginx image inside my container is because I can use Nginx as a load balancer, which means that whenever I'm scaling up or down my image or my app, Nginx will handle all the load balancing that I need, right? So that's why I'm having an Nginx container here. So yeah, again, image is Nginx latest. Volumes is, I'm just passing in the Nginx config and mapping it to the necessary, location on inside the container. env file, again, I'm telling it what file to use as the env file. Ports. Now, here I do have a colon, which means that the containers port 80, which is the default port that Nginx runs on, would be exposed to my host port. But because I've used like a variable syntax here, this port will be read from my env file. Okay. So I need not hard code it into my configuration. I can pass it as a env parameter as well. Similar thing, networks, I'm passing in the custom app network. Basically all three services are sharing the same network, and that's how they are communicating, right? And this depends on app, because I only want my Nginx to run if my app is running. That should make sense. Now for volumes, this custom volume that I mentioned here, oops, what was that? Yeah, the custom volume that I mentioned here, Postgres underscore data, I'm basically defining it here. And this driver again is not necessary, completely optional, I can skip that. And networks, because app underscore network is a custom network, I again have to define it here. So basically volumes and networks, I'm just initializing those particular networks and volumes respectively. Now as far as the Nginx config goes, remember I'm passing this or I'm mapping this inside my Nginx image. So what I'm doing is I'm creating a pool of my servers, and here app colon 5000, basically Docker is smart enough to resolve this app to the IP of this app, right? So that resolution happens internally. The server will listen on port 80. The server name would be localhost, because I am not passing it a domain name, right? Because it's inside a container. Client max body size is 0, because I don't want any like limits to be set by Nginx. And I'm basically proxying my backend, which is this entire pool of servers, right? And here I can mention any like load balancing strategies that I want. Like for example, least connections, right? Least connections. So this basically will tell Nginx that use least connections as the way of load balancing, etc., etc. This is very simple. Now, how does this actually help us scale? I'll log into my server to show you guys that. If you guys have any questions, you can go ahead and ask them. So first I'll do sudo docker ps to show all the instance, like the containers that are running. And like you can see, SWFT is the app that I just showed you. So I had named my services as DB, app, and Nginx, but they get prefixed with my app name, like actual application name, because they all belong to the same Docker compose file, right? So that SWFT get prefixed to that. And like you can see, I have exposed port 9003 here to Nginx, and that's how I'm basically hosting my website. But what I wanted to show you guys is I'm inside my folder, which means that I have a Docker compose file here. If I do ls, you can see there is a Docker compose file here somewhere. Here, it's right here. And what I can do is sudo, and as you can see, there's only one instance of app running. So now, as far as scaling goes, I can do this dynamically as well, but for now, I'm showing it to you manually. Say for example, now I am seeing a lot of traffic on my server, and I want to scale it up. I can just do sudo docker scale app equals, so app, this is the service name, right? I can also do db if I want to scale up the database, but I'll just do app equals 3. Okay, scale is not a docker command. Oh, is it docker compose scale? Docker compose scale. Yeah, it's docker compose scale. My bad. So what it will do is basically it's running one database container which was already running, one application container which was already running. It created Swift dash app dash 2 and it created Swift dash app dash 3 and it started those. So now if I do sudo docker ps, this is listing all the running containers. You can see that, wait, I'll need to do full screen. You can see that app dash 2 and app dash 3, that there are two new what do we say, instances added. And because I'm using nginx, if I check my nginx logs, that is sudo docker logs swift dash nginx dash 1, so these are the logs, right? Or actually if I just do sudo docker logs swift docker compose logs, okay, never mind. What I can do is I can take that service down. So sudo docker compose down. I didn't show you guys how to actually run it, right? So if I'm in the directory where my docker compose file is there and I do docker compose down, it will take down whatever instances it has created. And this is where I'm hosting my app. So you can see it'll go down, right? Bad gateway. We'll just wait for this. Any questions so far? I'll take that as a no. And we'll just wait for this.
Hey, अरे भाई
है question है?
I do have some question.
Yeah.
हाँ, question ये है कि I mean, can you share some resources about जैसे कि मतलब ये containerizing का like थोड़ा सा concept थोड़ा सा और clear हो जाए because एक घंटे में तो नहीं होगा ना, तो
Yeah,
और भी
yeah, makes
करना
sense.
पड़ेगा.
So okay, I'll get back to you. End में I'll share some resources.
Sure.
Yeah, perfect. Okay, so now my this thing is down. My entire app is down. So all of the containers basically that my Docker Compose file created, all of them are taken down. They are not removed or deleted. They are just stopped from running. So if I do docker sudo docker ps, none of them are running. None of them. I'll just do grep swft. So none of them are running. Now the way of running a particular Docker Compose file is you go inside the directory where the file is located. You do docker compose up. Now there are multiple different flags that you can pass. If I do -h, you can see -d would be running it in detached mode, which basically means it'll run it in the background. That is how you will essentially be hosting the apps, because you won't want them like inside the terminal. You want them to detach from the terminal. Another thing is you can pass in something known as --build, which means that if any of your code has changed or anything has changed, and you don't want it to use the cached images, because ideally what it would do, this is different from Docker, right? Docker checks your or the Docker config Docker file checks your code if any of the file has changed, but Docker Compose just checks if your image is created or not. So because we already have an image created, whenever you do sudo docker compose up, it will use the existing images to create containers. It won't rebuild the images. But in case of a change of code, you would want to rebuild the image, right? So you need to pass the --build flag to it in order to do that. Another thing is you can also pass in environment variables and ports, etc. But for now, I won't run it in detach mode so that we get all the logs. And again, now if I do sudo docker compose up, only one instance would be created, because my docker compose.yaml file only has one replica here. So I'll just hard code it to have 3 replicas. and then I'll do sudo docker compose up. Or actually, you know what? I'll show you how to do it while these instance is running. So yeah, I'll just do sudo docker compose up, and it'll basically run. So right now, because I haven't passed the dash dash build flag, it'll use the existing containers, like existing images, and it will just reuse those images. It won't rebuild the images. So yeah, that was relatively pretty quick, and you can see db-1 is our database, and the data, these are the logs that the particular app is printing. So first my database was up and running, then my app was up and running, and then nginx, because of the depends on configuration that I mentioned. Yeah, so that was the chronology. Now everything is up and running. If I refresh this, it should load my website, and I get the logs here. Right now what I can do is I can do here sudo docker compose scale app, wait, yeah, app equal to 3, and I'll need to put in my password. So yeah, it'll basically create 2 more containers of my app, just the app, right, not the database, not nginx, and it will run them. And that you can see here, because the get requests will go to different apps. So right now it's app-1 that's receiving all the get requests, again app-1, but now you can see app-2 is running, app-3 is also running. So now everything has started, and if I refresh this, so now the first get request went to app-1, again app-1. Okay, wait, I haven't mentioned the round robin criteria, right? But essentially I have 3 instances running, and then the load gets balanced according to however I want. Right now, because I haven't mentioned in the nginx config that use round robin or what method to use, it basically will serve all the requests to app-1 until that can't handle requests anymore. Then it'll use app-2, and then it'll use app-3. I hope that made sense. Yeah, any questions you can ask them again. Yeah, I hope you understood how to scale containers. And imagine doing all of this in the traditional sense of cloning the git repo and then building like installing the dependencies and then running it that way. So yeah, that is a hassle, and that's why we containerize app. Actually, let's look at docs, like some resources. So the best place I would suggest is the Docker documentation. So if you go in guides, there are different guides, how to set up your cloud for Docker, securing your software, etc., etc. Another thing is manuals. So this is again this is more of like tutorials, or how to do it, etc. But if you want like proper resources on what containerization is, etc., etc., the approach that I take is ChatGPT. Like I literally use it for everything. I can literally ask it, I have a simple Flask app that acts as a backend. Give me a Docker file. So ChatGPT can generate that. Similarly, I can also ask it, what is containerization? How can I do it? What is difference between Docker and Kubernetes? I don't know if Kubernetes का spelling correct है कि नहीं, but yeah. So yeah, basically you can do this, or another good place is Perplexity AI, because it will give you sources also. Oh, it's down. You can use mini that it's developed by one of my seniors. So yeah. Okay, give me resources to learn about containerization and Docker. Yeah, again, this is like a simple, it'll give you all the commands that you can run. So ChatGPT is your, or AI in general, is your best friend in all of this, because all of this does not require it's configuration basically, right? Again, yeah, pushing and pulling I didn't talk about. I'll give you a brief overview about that. Here you can get like resources, Geek for Geeks, Coursera, etc., etc. It'll also give you a summary. This is basically how I learn about stuff, and YouTube videos, obviously. But yeah, and pushing and pulling, right? So Docker, the benefit of having images, Docker images, is that you can basically build the image, and then on your server you can pull the image, right? So Docker Hub itself is one such place. It's a registry for Docker images. You can sign in and upload, etc., etc. But there is a downside. It's not entirely free, or it is free, but there are some limitations over it. Uh, where would we find it? Pricing. Okay, wait. Uh, Docker Hub limits. Sure, usage and rate limits. So on the free account, right? Here, personal account, you have unlimited public repositories and like storage, etc. You have one private repository and up to 2 GB private repository storage. There, I don't think are any pull limits, but there are limits to pushing like your Docker images. You can't upload too many Docker images on Docker Hub, but you can host your own Docker registry, uh, and that also happens via a Docker image itself known as registry. Oh, it's in Docker Hub, not here. Registry. You just have to run this Docker image basically to run your own like Docker registry, but that's not the like the topic for this particular uh, webinar. I'll just show you a simple example of how I can, you know, push and pull the Docker image. So I'll build this first. So that is Docker build dash t sfwt and then dot. By the way, Arnav, did I answer your question for resources? I'll take that as a yes. Okay, so now I have built the image. What I can do is I first need to tag it, right? So Docker tag my local image. Wait, what did I? Oh no, this is my server. Never mind. I can just do this. Yeah, I built the image, so I can do Docker tag local image to. How do you push it to Docker Hub? Pushing to Docker Hub. Docker push. And okay, so I don't need to tag it because I'm pushing it to the official Docker Hub. So I can just do Docker, Docker push this thing. So as you can see, denied, request access to resources denied, because I need to log into the Docker Hub like repository. I can just do -u. I can put in my password. Just a second. Yeah, so login succeeded, and now if I push it, it should work. Okay, it's denied. But basically, if I had my own custom, repository, so I would do something like docker login docker.nisarg.in. I would put in my username. I would put in my password. It would work ideally, and then I could push it to that particular repository. And similar with pulling, you just need to do docker pull and then something like, you know what? I'll show you some cool applications of Docker. If you go to Docker Hub, you can technically run some OSs inside your terminal itself. Like one that I know of is like the Raspbian OS that is used on Raspberry Pi. Uh, Raspbian, right? Or Raspberry. Let me just search for Raspberry Pi. Okay, no, so it should be Raspbian then, because this is a Raspbian. Okay, it's not here. I can do a Google search of Raspberry Pi Docker image. Yeah, Raspberry Pi OS based images, Docker. Here. So I can do something like Docker run dash it basically means for interactive and then terminal. So basically you're running some command inside the container. Wait, there was some error. No matching manifest for Linux AMD. What? Wait, is this the wrong one? Here, okay, this is the correct one. Nope. Uh, why does this not work? Or I can use something like Ubuntu also. Wait, I can just do. So if you do Docker run and then dash help and exec, nope. Grep exec, nope.
I think you're looking for Debian.
Uh, Not really Debian. I was looking for Raspberry Pi OS, but it's okay. I'll just use Ubuntu. But yeah, there are basically you can also run you can run commands inside a container using the Docker CLI. So it's something like Docker run. No, it would be Docker exec. Then you pass in the container name. I'll actually show you that on a running container. And meanwhile, I can also do this. Okay, this happened. Sudo docker ps, or I don't need ps. Wait, cancel. Sudo docker exec and then the container name, so swift slash app slash one, and what I want to execute, so that is ls. So yeah, like you can see it's executing like or I can do something like ls slash app slash data. So here these are the files inside the data directory inside my container. So I can use docker exec and then the image like the container name or the container id, and then I can pass in a command that will run inside that container. And similarly I can uh, use run dash it and ubuntu, so it'll pull in the image first and then it'll basically, so dash it basically allows me to like basically run inside the terminal of the image. So if I do something like, I don't think neofetch is installed, so sudo apt install neofetch, sudo not found. Okay, yeah, because this is, but like you can see apt does work, which means I'm inside ubuntu right now. So you can technically use this on windows system to run some linux commands, etc, etc. With that, I think we come to the end of the session. If you guys have any questions, you can feel free to ask. And before that,
What server was that?
what server was that? The one that I logged into or the one that is
Yeah,
running
yeah,
right now?
when you logged into.
That was running Arch. So it's literally a laptop running like on my home network that I'm using Cloudflare to
So it's
exploit.
how it was laptop only. Okay.
Yeah, so this is like a idea pad that I'm running. It's running Arch, which is technically server shouldn't be running Arch, but I love Arch. So plus I have physical access to the hardware, so if anything goes wrong, I can technically fix it really quickly. We love Garuda. I don't. Okay, I like very minimal distros and like OG distros. So, okay. Before we go to the questions, you nisarg.in is my personal website. You can connect to me on LinkedIn, or you can drop in a mail from like you can get my socials from the website, and also my projects, blogs, etc. Hopefully this should load quickly. Firefox is just slow sometimes. And yeah, let me just do it here. Or my internet is slow. One of those two. Okay, it loaded here really quickly. Yeah, so this is my like personal website, you can get my LinkedIn, GitHub. I don't use Twitter really, and you can get dev.to. You can also subscribe to my newsletter.
Time to
I
drink water, you
very
stupid human.
rarely, so like maybe once in a couple of months, send a newsletter out, and it mostly features some new open source technology that I find really cool. Like my last newsletter was about something known as Umami, which is like an open source alternative to Google Analytics, which I'm using for a couple of my websites here. So you can see this, like one current visitor, etc., etc. Yeah, I think that's it from my end. Any questions that you guys have? Hackintosh. I mean, you can try it if you like, but I don't. I like my OS really. Like I like my OS a lot, so I wouldn't like use a Hackintosh regardless. But yeah, I think
बाय
that's
द वे
yeah. Yeah, no.
रिकॉर्डिंग सेंड कर देना, ठीक है?
ओके या परफेक्ट. हाँ, मैं रिकॉर्डिंग भी भेजूंगा एंड लाइक अ शॉर्ट पीडीएफ ऑफ नोट्स एज सच इफ यू वांट टू रेफर टू इट.
या एक काम करना कि रिकॉर्डिंग को यूट्यूब में अपलोड करके तो वो तुम फिर लुमा में जाके ब्लास्ट से अपलोड करते से दे देना, हो जाएगा, वहां पे सबके पास चला
परफेक्ट
जाएगा.
परफेक्ट.
ओके.